Okay, last night I asked you to do the first 7 questions on this sheet, displacement, velocity, and acceleration. Now I only asked you to do them for Friday, but now that today's a snow day, your test will be tomorrow. And so please try these 7 questions, and then come back here and make sure you did them right. So that then over the break, you'll be able to do the ones that I have planned for you then. All right, so question number 1, I just need to move the sheet out where I can see it. A biker passes a lamppost at the crest of a hill traveling 4.5 meters per second. So VI is 4.5 meters per second. She accelerates down the hill at a constant rate of 4 meters per second squared. So A is 4 meters per second squared for 12 seconds. So that's my delta T. And the question wants to know, how far does she move down the hill in this time? So you're looking for delta D. So then you say, okay, what equation do I know that has a VI and a delta T and a delta D in it? And it's one of our brand new ones from yesterday. So delta D is equal to VI delta T plus 1/2 A delta T squared. So write the equation down first. And look how nice I was. You don't even have to rearrange this one. Sorry, I put my hand in there and I messed up the focusing. You don't have to rearrange this one, and it won't focus for me because you're looking for delta D. So delta D is equal to 4.5 meters per second. Remember, fill in your units, times 12 seconds plus 1/2 4 meters per second squared times 12 seconds squared. All right, so 4.5 times 12. 4 times 12 is 48, and then another 6. So it should be 54, I believe, in the first term. And then 12 squared is 144. Half of 4 is 2, so 288. And that's also going to be meters. So add these together, and you should get 342 meters. Oh, look, and that's what I have as the answer. Okay, number 1, done. Number 2, an airplane accelerates from a velocity of 21 meters per second. So VI is 21 meters per second at a constant rate of 3 meters per second squared. So A is 3 meters per second squared over 535 meters. So delta D is 535 meters. What is the final velocity? You are looking for VF. So what equation do we have that has a VF, an A, a VI, and a delta D in it? It would be our second new equation. VF squared is equal to VI squared plus 2A delta D. But you're going to, oh, no, you don't have to rearrange for VF. That's what you're looking for. So VF squared is equal to 21 meters per second squared plus 2 times 3 meters per second squared times 535 meters. All right, VF squared equals 21 squared is 441 meters squared per second squared plus 2 times 535 is 1,070 times 3, so 3,210. I think, doing it in my head. So VF squared will equal 3,651 meters squared per second squared. Take the square root, and if I did this correctly, 3651 square root, you get 60.42, and the good news is that's what I say the answer is on the sheet, so I must have done it in my head correctly. All right, number 2. So moving on to number 3. A race car can be slowed with a constant acceleration of negative 11 meters per second squared. And please note, I was nice here and put the negative on, but I really didn't need to because I said slowed, and that should have told you the negative was there, so I won't always put the negative there. If the car is initially traveling 55 meters per second, so that's my VI, how many meters will it take to stop? So VF is 0, and you're looking for how far did it go to stop, delta D. What equation do I have that has a VF, a VI, an A, and a delta D in it? Exactly the same one I just used above. So VF squared is equal to VI squared plus 2A delta D, but this time I have to rearrange for delta D. So first step, take the VI over. So it becomes VF minus VI is equal to 2A delta D. And now to get the delta D alone, divide both sides by 2A. And so we'll have delta D is equal to VF squared minus VI squared over 2A. And now you can fill your numbers in. So VF was 0, VI was 55. So 0 meters per second squared minus 55 meters per second squared over 2, and A was negative 11 meters per second squared. Okay, so this just disappears. So in the top, you get a negative that doesn't get squared because it's outside the bracket. So it'll be negative 3,025 meters squared per second squared, and on the bottom, negative 22. And when you divide the negatives, they cancel, and you should get 137.5 meters. Okay, number 3, done. Number 4 says, a person wearing a shoulder harness can survive a car crash if the acceleration is smaller than negative 300 meters per second squared. Assuming this constant acceleration, so 300 meters per second squared, how far will the front end collapse? How far? You're looking for a delta D. How far will the front end collapse if the car crashes going 101 kilometers per hour? So VI is 101 kilometers per hour, and we're assuming it's going to come to a stop. That's why the front end is going to crumple until it stops. Oops, so that's not a question mark, that's a 0. Meters per second, you need to change your kilometers per hour into meters per second, and you do that by dividing by 3.6, or multiplying by 1,000 and dividing by 3,600. So divide by 3.6, and you get 28.05, and the 5's repeating, meters per second. All right, so what equation do we need to use if we have an A, one a delta D, a VI, VF? Exactly the same one we used above. So VF squared is equal to VI squared plus 2A delta D. And again, we're rearranging for delta D. So VF squared minus VI squared equals 2A delta D, and then divide both sides by 2A. So VF squared minus VI squared over 2A. Again, the VF squared is 0, so this is going to be negative bracket 28.05 repeating squared over 2 times negative 300. And again, the negative on the top doesn't disappear. It's not inside the equals. Okay, so square your negative 28.5 repeating, and you get on the top negative 787.11, etc. meters squared per second squared. On the bottom, negative 600 meters per second squared. Divide by negative 600, and you should get 1.312. And it works out to be positive because the two negatives cancel it. And I didn't round, I left all my digits in my calculator there, so if you're getting something a little different, it's because you must have rounded. All right, that's number 4. Number 5, I think I might have enough room for number 5 down here. Oops. Number 5 says, engineers are developing new types of guns that might someday be used to launch satellites as if they were bullets. One such gun can give a small object a velocity of 3,500 meters